Welcome back everyone to another Technique Coding programming tutorial. We're going to continue on our iOS authentication app. What we left off on last time was we finished off all of the views, so we have a login screen now, a registration screen, and a screen we land on after we log in. We didn't hook up anything though. We have the navigation finished. We added a coordinator, so we're using the coordinator pattern in this app to navigate around. And we hooked up all the navigation in the app, but it's not actually doing anything as far as sending stuff to the back end and getting responses back. So that's what we're going to do today. We're going to actually make the code that will not only make network requests, but also handle the token. This is probably what most people are waiting for. So we're going to make our own little file that will handle all the token accessing and storing, and we're going to do that using Keychain. So as a real quick review here. So let me bring up the app. So this is what we finished off with last time. So as you can see, we have a login screen with super simple. We can hit the register button to go to the registration screen. Of course, it doesn't do anything now when I hit register other than navigate back to the login screen. We can hit the login button down here to navigate back again, or we can hit this little back button that iOS is nice enough to give us out of the box because we're using a UI navigation controller. Or I can hit the submit button to navigate to the screen that we are using as almost like a dashboard or a home page. And then I can hit log out to go back to the main login screen. So that's all we have right now. This is all pure navigation views. So for today, just getting started into this, what we're going to do is we're going to add the boilerplate for our network requests and to handle our token storage. So the first thing I'm going to do is I'm going to close down or just minimize some of these things. I'm going to add a group called errors. So this is in I should probably spell that right. This is in preparation for the things that we're going to need for error handling. But it's nice to have these errors in place before I start coding some of this network logic, because it's easier to then reach a point where an error will happen and then we can handle it with our current errors. I don't like going back and forth, but in reality, when you're in the middle of development, you probably are going to end up adding these as you go along anyway. So let me just say error. And technically speaking, you could just make one that's a generic one if it's a super simple app that just passes back a string and you can handle that string accordingly. But in a real life app, you are going to separate these into individual errors. So what I'm doing here is I'm just saying that we couldn't unwrap a value we need to make a request or to handle a keychain. Say new file, we're going to have a form error, and that one is just going to have two cases in it. So one for missing fields in case the user doesn't enter a password when they're trying to log in. We can throw this error so we can tell the caller what happened. Incorrect entries, this is more like validation. So if a user doesn't enter a correct email, we're not going to do email validation on this, but what we're doing is we're doing a validation based off of the registration form. So if a user doesn't enter the confirmed password, which matches a password, then we just throw this error and we can handle it correctly in the UI. Next one we're going to have is a keychain error. This one's going to have three cases. Then the last one we're going to have, and this one's going to have the most cases in it, is a network error. Okay. sort these. Already sorted. Okay, so for this one, be a few of these, and I'll write it out and I'll explain it after. And I'm messing everything up here. Sure that everything's all good here. Okay, so when we're dealing with network errors, there's quite a few things that could actually happen. We're not encapsulating every single situation here, but we're trying to give some good defaults. So user error basically means that if the user did something they're not supposed to, which is usually a 400 error. So if the backend says, hey, we didn't get the right things or what have you, that's usually a 400 error. Data error is if anything happens with the data, then we can pass in a string to explain like what happened. Same thing with this string up here. We can pass up or tell the caller, which is receiving the error, what happened with the user error. Encoding and decoding has to do with JSON encoding and decoding. What we're going to see here is we do have a payload that we're going to use the Codable protocol for to encode our requests as JSON, but really that happens kind of like not behind the scenes, but the Codable protocol helps us with that. And if any kind of decoding or encoding into or from JSON fails, then we can throw these two errors. The failed status code is pretty self-explanatory. It just tells you what the failed status code is, and this is a special case for the same thing, that if we get a failed status code, we can also pass back the status code with the data that was sent to us from the backend. This is an easier way to handle it if the caller needs to handle it specifically for certain situations, like if we have a authentication failure, we can say, okay, we can refresh the token we're going to get, but we have to know what the status code is. Usually that happens on I believe it's a 401, if I can think correctly here. Yeah, it's a 401 error code or status code when the backend tells us that we're not authenticated. So if we are authenticated, have an access token on our app or saved in Keychain, then if we get a 401 response, we know that the token is either expired, revoked, what have you. If we have a refresh token saved as well, we can use that to fetch a new token and then retry the request. If all that fails and we still get a 401 back, then we log the user out. That's usually how it works. The no response is usually just a 404, no response or not available. The status code response data right here, all we're doing is we're just returning the status code and the response data if the current state is the failed status code response data. This is more or less just a convenience to return it rather than having us go in and create like a case statement to unwrap it, or if case let statement to unwrap it. We're just doing that through an easy accessor, because I can't tell you how many times I forget this syntax every single time. For some reason, I just cannot remember it. So I usually just give write really easy access or CR. So those are our errors. The next thing we want to do, we don't want to go into the storyboard launch screen, is our model layer. Now this folder is the spot we store everything. So the first thing I'm going to do is I'm actually going to go over the access token stuff first. I think a lot of people are going to wonder what you do here. So I'm going to say system. And I don't know if you saw that, but Xcode does have a little bug where if you're making a new directory, for some reason the first character doesn't show up when you start typing. This is Xcode 15, by the way, so it might be changed if you're viewing this at a later date. So what we need to do is we need to create an access token. Now this is going to be adopting the Codable protocol. So this is one of those things we're going to encode and decode to and from JSON. And we're going to do that using the Codable protocol. Oh, can't type here. And that's not what it is. We just say refresh. Okay. So if we go into this Codable protocol, and I'll just review this really quick, you can see that it's just a type alias for adhering to the decodable and the encodable protocol at the same time. So and just basically says it is adhering to both of them. So if you want to chain a adherence to a protocol, you could just use this little and symbol. So that's it. I'll let everyone watching look into the Codable protocol by itself. It's very handy. I used to, before I usually started using this, I used to manually type out like the JSON fields I would use that came from the server, and then I would map that out into an actual object. This is nice because the Codable protocol basically says, hey, these fields that are here that are listed in the coding keys, I can try to decode from a JSON payload using these coding key values that are listed right here into an access token object that's decodable. Encodable basically just says I can transform this into a JSON payload or a JSON object that uses these two fields. Now, if the fields that you receive or you send out to the server are different, usually you'll see something like this where it's in snake case where they have this little underscore in between. All you have to do is have your coding keys adhere to string and then say equals whatever is listed here is what the JSON object will encode to and decode from. So right now, this Codable struct is looking for fields named access_token. And if it doesn't find one, then it's not going to actually work. It's going to fail. Now, you can override the encodable fields and the codable fields to be a little bit more granular here. So you can say, if this doesn't exist in the JSON payload, just still create the object, but make this into like an optional. So there's other things you can do in this that's way more powerful. But just know that what we're doing here, we're listing the name of the fields that's going to be sent in the JSON payload, and we're telling the Codable protocol how to actually, what fields to look for and what to map them to right here. So that's it for the access token. Now we can get the response from the server and map it out into an access token. The next thing we have to do is we actually have to store this somewhere. And we do that using Keychain. So let me make a new class or object here. Usually you want just a spot to put this, some kind of management object. However you organize the app is, put it into a spot that makes sense for your app. Now, personally, I might consider making this into an actual protocol, so protocol-oriented programming, but for this, we're just going to make a struct. And the first thing we want to do is we want to say import security. This is Apple defined. We're not using any third-party packages. This is still built into the Apple ecosystem. A struct access token storage. And we're going to say private let account key equals com.tech coding.auth class token. All right, so this is going to be really important. You have to have a key to save a value into Keychain and also to retrieve it. Think of it as a dictionary, basically. It's a big dictionary. So this key, because you were working with Keychain, you want it to be as unique as possible. Try to make even user default keys as unique as possible. The easiest way to do that is to use the reverse domain structure that you use to submit an app to the App Store or your bundle ID. And then if you have multiple account keys, what I do is I just say, com.technicoding. Whatever the name is that it's associated with, and I keep those around. These can be hard-coded. If you want like an insane amount of security, I suppose you could send this from the back end, but it really doesn't make sense. Usually what we do is we just handle it by hard coding it somewhere. There's another way you can hard code these things, and it's actually in the build settings, but I'm not going to go over that too much right now. Come to think of it, I might have actually... No, we haven't done that yet. We will be going over this in a little bit. But in any case, we have to have an account key. So next thing we're going to do is we're going to say func save token and our access token object. And we're going to return a bool that tells us whether or not it was successful. The first thing, and because this actually relies on another one, we are going to make a delete function here. Okay, so before I finish the save method, we're going to make the delete method. We're going to say func delete. Cool. Now here's where we start to get into Keychain. So let me type out this. There's only 3 lines of code right here. So let me type this out real quick and I'll explain what's going on. Okay, so when you're working with Keychain, you basically have to write queries for the Keychain. It's almost like a little tiny database. And to do that, we have to construct the query on what we want to do. So we basically say, and it does that through another dictionary. CF strings is just another, I think it's core foundation. But anyway, it's using strings and then values to tell Keychain what to do and how to handle it. So to do that, we say k-sec class, and the class is basically a generic password. So we're telling Keychain that we're dealing with a generic password here. And we have to tell it, okay, well, under what account? And the account is that account key. Basically saying, what value are we looking for in Keychain to manage? And we're saying look for a value that's defined under the account key that we had here. And then we use a sec item delete. We say delete query as CF dictionary because that's what this expects to be put in. And it's going to return a status on whether or not it was successful or not. Then we just check to see, and this is an enum too. So this, if you look at it, it's an OS status, and I'll let everyone else take a look at that on their own time. But basically all we want is to tell whether or not the status was successful, and then we return whether or not it was. And that's how you delete it. Adding is much the same way. So right here, what we can do is we can say just delete. And then we don't really care about the response on there for this one. So we can just say at discardable result for the delete function. And we don't care about it because if there isn't an access token, then we already are in the state that we are desiring here. If there is an access token, then mazel tov, you know, it's done, it's deleted. So we don't have to worry about it. So the first thing we want to do is we want to say guard let data equals try. And this is where we encode for the first time with JSON. JSON encoder dot encode our token. And let's see here, else return false. So basically when we're saving to Keychain, we really want to try to save only simple values, like primitive values. So this will encode it into a data object, which is one of the values that we can use in Keychain. We can't really save it as an actual token object. It doesn't do that for us. So we need to encode it into a valid type that Keychain allows, and one of them is a data object. So now we have to actually make the query to tell Keychain what to do with this data. And as you can see, there are a bunch of different classes you can use for this, and you can use more than one too. So the sky's really the limit on what you want to do. But because we're just doing normal token authentication and handling a secure password, all we need to worry about is just handling it as a generic password. And Keychain will do the rest by encrypting it, keeping it secure, what have you. Keep in mind though that when we're doing this, if the user uninstalls the app and then reinstalls it, these values will still exist in Keychain. So that's really important to know, because if someone is trying to say uninstall the app and then someone else who also has usage of the phone installs the app's going to say, oh, we're already logged in because we already have this access token, or however you have the app set up. So usually what we want to do is we want to, on app launch for the first time, we have to make sure that this value doesn't exist in the Keychain. Let's see. So the next thing you want to do is just want to say ksec header account. And we're going to say account key to specify what we're looking for here. And I'm going to clean this up a little bit. Ksec value data. The next code is still bothering me, so I'm going to do Control I, formatting, and I guess the formatting doesn't want to do what I want it to do either. It's fine. Cool, so now we have a query. We're saying that it's a generic password. It's under the key that we have defined here, and we're going to say we want this data to be the secure value that we store. So now we say let status equal sec item add query as cf dictionary. Now, if I can remember right, there's actually another argument here. What is that? Unsafe mutable pointer to the type ref, the result. We don't really care right now. All we care about is whether or not it succeeded or not. Reference to nearly is. So this will do it. So now we say guard status, or we can just say return status equals success. And this is it. This is what we need for saving and deleting. Now, we also have to fetch it. So next thing we want to do is we want to say also, sometimes we don't care about this, so I'm going to add the discardable result again for the save method. So now what we want to do is we want to say get. Same thing as last time. We're going to build a query. Now, for this one, I'm just going to copy what we have in the save because we're going to use a bunch of the same things here. So we're going to say, this is we're going to keep this too. We are not going to have this data value here, but we are going to have a ksec return data true. So we're telling Keychain that we want the data returned in our request. Say ksec match limit ksec match it 1. We only want one result. If there happens to be multiple results for the same key for any reason, then we're just going to say limit to one result for us. There's a lot more other keys in here, and there's way more you can do with Keychain, but this is the bare minimum when it comes to saving and fetching access tokens. So then we're going to say var item cf type ref status equal copy matching query as cf dictionary, and we're going to say item. Now, if you're not familiar with this little and sign, all that means it's an in-out property or parameter. So in-out parameters, basically, they are used with reference types. So when I pass this item in, this function is then going to add or update this property with the reference. And then after this function is done, I can use this item later on. So that's all it is. It's just saying I'm passing this item in, but I expect this property that's defined right here to be handled and updated within this method. Usually when you don't have an in-out parameter, when you pass it in, it's copied. And it's not necessarily true that the memory location that you're passing in is going to be the same. Usually it's copied. That's why they came out with these in-out parameter definitions to keep things clean, but also keep things less risky when you're coding. Say guard status equals just guarding against this. Actually, it's going to be nil. Saying that if we don't have a success in fetching it, then we don't have an access token, so just return nil. So now we're going to say guard let data equals item. It's data else return nil. And another one. Sometimes it's useful. Now, I probably should right now, just do something like this and just handle both guard statements. Data equals item as data else return nil. Now, the reason that I sometimes don't do that is because multiple guard statements allow me to log different errors depending on the situation. If you have one big guard statement here, you'll have to then inside the else block here, you have to then say, well, why did it fail? How should I log this? Much easier if you have multiple guard statements, but not always necessary. So now I have to say, I'm going to say return try, and we have the data. So now we can actually try to construct an access token from it. So we can say try JSON decoder dot decode. And you have to tell it what type you're trying to decode into from data. So we're saying this can throw, and I can't spell today. Story of my life. So this will throw because this can fail. So we're just saying try, and if it fails, just return a nil object instead of having to do a do catch block here. And we're saying decode into an object access token dot self. Dot self just says it's just defining the type rather than passing in like an access token instance, and then saying from data. That's it. So we've got our save method right here, which is constructing a keychain query, and it's just saying add the item to it. We have our getter here, which is doing the same thing, just creating a query using the correct keychain method to fetch or use that query in whatever way you want. We're handling the status, and then we're returning everything we need. And then the delete is the same thing. That's it. That's all a keychain is involved in right here. Now, there's third-party libraries you can use for all this, but honestly, if you've just got keychain as a token storage device, like, this really isn't, I wouldn't pull in a whole library just for this. I have in the past because I didn't dive into like what's involved in actually making a keychain request, but this is not that much code. The scariest part of this is just the queries. That's basically it. They do have a lot of different dictionary values and keys you can use on here, which is probably the most intimidating part. You have to go in and learn what these are. But as long as you've done this once, we've got a class of less than 50, altogether minus empty space here. We have like 50 lines of code that you can just copy and paste in each project. Not that much. That's it. That's all of our keychain stuff. We're done with that. Next thing I want to do is I want to go over the network layer. This is where things are going to start getting a little interesting. So first thing we want to do is I'm going to make an object that we're going to fetch. That's going to be mapped out from the JSON response when we fetch secure data from the backend. So I'm just going to say secure fetch data. Same thing like the access token we just made. We're going to say struct secure fetch data, and we're going to say Codable. Now, you're not going to see me use the coding keys here, and there's a reason for that. Coding keys is only really necessary if you have a special situation where the payload that you get from the server or the JSON object, the fields do not equal the field names that you have here, right? So if you have a specific need or you have to map these keys out differently depending on what JSON objects fields are, that's when you actually go in and start customizing it a little bit. However, when they match, this is all you need. You don't need the coding keys. So when we're fetching the secure data from the backend, it's going to send us a JSON payload that only has a message field on it. That's it. So this represents the entire payload. Because the name is exactly the same as the name of our property here, we don't need a coding keys. Codable protocol behind the scenes will automatically map it out based on the name of these fields. So that's it. That's all we need. So now is probably the most complex part of this entire process, and that is going to be our network handler. This is, I'm going to move this up to be alphabetical here. This is going to require a little bit of boilerplate. It's not going to be too much code, but it does require a little bit of effort here. So we're going to say enum http method. I like to do this just because use this enum because it's just a lot easier. Once you get into it, case get post. From my experience, whenever you find yourself constantly using string values to define anything, find a way to make those into auto-completable properties, enums, or what have you. I've seen projects that will just copy and paste the string value all over the place. Now, if you want to change that string, which is fine with HTTP methods, but when it comes to things like database accessors or queries or something like that, it's much, much easier to change a property value than it is to find that string all over the code base and try to change it again. And believe me, this, for some of you, it might seem like common sense. Like, yeah, that makes sense. Like, why wouldn't you do that? I have seen code bases where novices have entered and basically run amok, where they have over 60 to 120 different instances of one string as a query into a database. So if a table name changes, all of them have to change. So just as a side note, now we want to make a content type. Now, adhering to the same pattern that I just mentioned, we're going to say case JSON equals application slash JSON rset equals UTF-8. Now, what we're doing here is whenever we send a network request, we are going to be sending it with JSON. So we have to we have to basically specify in the network request that we are sending and receiving JSON. I don't want to type that out each time, so I'm just putting it in this content type enum so I can fetch it whenever I use it. Now we say class network handler. This is going to handle all of our network requests. Now, I might refactor this into a different type of thing. Basically, I usually have all my network requests in a protocol, but just for the sake of this, I'm going to leave everything in a class to not go overboard on this. And the reason I usually put it into a protocol is it's more easily shared, more easily testable. But also, I usually have individual network objects, such as an API. We'll call it like a REST API or a RPC API, which is just a remote procedure call API. And then those would adopt the network handler protocol, which has all the request functions in it. Because I don't need that architecture, I'm not doing it that way right now. But just as an FYI, that's usually how I do it in production. So we're going to say func request, and this is going to be a doozy, but we're going to say URL JSON dictionary, any, well, optional, nil. And we're going to have quite a few parameters in here. So I'm going to wrap these. Okay, so we have the URL object, which this points to wherever we're trying to make a request to. The JSON dictionary, which is going to be anything really. Then we have an HTTP did string equals HTTP did.get.raw value. After I'm done with this, by the way, this is pretty much what AlamoFire does. AlamoFire, if you're not familiar with it, is a third-party package that a lot of people use to handle network requests. Now, they do have some pretty nice things out of the box, but this native functionality is, once you do it a couple times, it's so easy to use, you might as well just use it. I'm currently in the process of ripping AlamoFire out of all my projects because of how easy this is, and dealing with more dependencies has just become such a pain. So in any case, the next parameter we need here is content type string equals, so we just leave this as a non-optional, content type .json .raw value. We're going to say access token. I have this down as an optional, but just in case we want to do something strange in the future, I'll leave it as an optional. Now, it's important that we don't somehow set this access token as a default value in any way, shape, or form. The reason for that is, once you're logged in, most of your requests are all going to be required to have an access token, but that's not always true. So say we're trying to fetch data from an RSS feed. We're not going to want it, we can't use an access token for that. There's no access token, or there might not be. Or if you want to just fetch the HTML from a site. So you want the ability to just set this to nil when needed. Okay, so now within this, we're going to say var URL request equals something. Now, this is at a point where we're going to stop and move on to a helper method here. And the reason for that is creating headers. So creating a URL request. This is basically so common, it's always used, that we are going to make ourselves a helper method here for that. Nope. Handler. Okay. Turn a URL. There we go. Okay. So now what we're going to do is we're going to have a few properties here, or parameters. Say URL. So whenever you're using the native network stuff inside iOS, you need a URL request, and that request is then going to be used to send the actual request. You use a URL session, and then you tell the session to make a request, and the request object is what tells the URL session what to do. So, but since across all of this, we're going to be using JSON, our requests are going to be pretty similar, just with a few variations. And they're so similar that we don't have to type it. We shouldn't have to type it out each time. We're going to say URL is URL, say HTTP method, say string method get raw value, content type, the same as last time. Raw value. Then we're going to say access token string equals nil for all the same reasons we just talked about. Now inside this, we're going to say var request URL request with the URL. And then we have to, just for the sake of the errors, we're going to return it right here. And then we're going to say URL request dot HTTP method equals HTTP method. Now is when we want to start configuring things. Now, it's not a guarantee that we're going to have JSON as a content type, so we want to make sure that we set it only when the content type is, well, JSON. We also want to say only set the content type if the content type is passed in. Say if let content type. And now with the new versions of Swift, we don't actually have to say equals content type. We can just leave it like this, and then Swift, through the context and the scope of this block of code, Swift knows, hey, is there a optional property named content type that I can unwrap here? And it's going to say, yep, there is. So we're going to unwrap it if it can be unwrapped. So just a little bit less boilerplate code for you. URL request dot add value, say content type for HTTP header field, and that we're going to say content type. Now I could put this in an enum, but since we're making this function reusable, I'm really only going to use this in one spot. So I'm going to keep this raw string where it is. Same thing with the next thing. I'm going to say if content type dot range of JSON not equal nil, basically saying, hey, does this content type include the term JSON anywhere in it? If it does, we need to send the accept. We need to add the accept header field in this to accept JSON back from the server. URL request dot add value, content type, and then accept. So here we're saying that the content type that we're sending to the server is JSON with content type. And then here we're saying that, no, just range. Then here we're saying that we also want to accept the content type of JSON back. Okay, so now say if let access token equals access token. You can actually remove that now. let authorization key equals bearer space, add a space there, dot appending access token. Say URL request, there we go. Add value, authorization key, or authorization header. Okay, let me explain this. Because the backend is what actually defines what type of authorization this is. So this is bearer authentication. And you can also have basic authentication, for instance. Now, we're a bearer of a access token, so we're going to use an access token. When you're constructing the value of the authorization header field, you say bearer, and you have to add a space, and then you add the access token after that. Now, this space is very important. When I first learned how to do authentication on the back end and the front end stuff, it took me, this is embarrassing, but it took me 24 hours to figure out I was missing a space because none of the documentation said, I thought that it automatically mapped it out, but in any case, you have to have this space there for that to work. And then we basically just say we are setting it on the header field authorization, and we are authenticated if we have the access token passed in there. That's how it's done. This is probably the one spot where these network requests can get just cumbersome, setting this each time. But now we don't have to. We can just reuse this. So coming back up to our original request function here, now we can say make URL request. We say URL here. HTTP method is our HTTP method. Say content type. We're just passing in everything we had up top. Token. This. Oop, there we go. Okay, so now we have our request header. Now we can make the request. One thing to note, I have this as async. So whenever you make a network request, you do not want that to be on the main thread. If you try to send a network request on the main thread, it's going to freeze the app. So we use the new async await syntax in order to prevent that. And I'll show you exactly how that happens. But basically, we'll use tasks to open up another thread, handle it, and then we will be passing our payload or what we received from the backend to the main thread once we're done handling it on the background thread. So that being said, we're going to say if let JSON dictionary let HTTP body equals try JSON serialization dot data. This is actually static. Dot data with JSON object JSON dictionary. Return. So just so this is going to do it. I just want that error out of the way so everyone can see. Let me open this up a little bit too. So we can say URL request dot HTTP body equals HTTP body. So we're just saying like, hey, if there is a JSON dictionary, then try to serialize it into a data. I believe this is data object, and then pass it as a HTTP body. Else, if JSON dictionary not equal nil, we're going to say could not serialize object into JSON data. And this is where those errors come in that we did originally. Configuration error dot nil object. Now, if everything goes according to plan here, we're going to be down here. Now we can actually make the request. So we can say let data response equals try await URL session dot shared dot data or URL request. This is what actually does network request. So this is what blocks too. So this method will be handled on a separate thread. inside this scope of this block of code, we're already in a separate thread. And this is basically saying lock, or not lock, but block that separate thread and handle this network request. So it's basically it's just going to block it, which is why we can't put this on the main thread. Now we have to handle the response. Guard let HTTP response equals response as HTTP URL response else message equals gonna create HTTP URL response for URL request.url absolute string here, and then we say print message and throw network error dot response, or no, that's not right. Dot we'll say I guess we'll say no response. But technically, we didn't actually have to map this out. I was going to use this as an error message to throw as well. But for the sake of this, we're just not going to do that. Okay. So if we didn't get a response, then that's a problem. So we have to throw an error. No response. Now that we have said that we do have a response, we're going to say let status code equal HTTP response dot status code guard 200 dot 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 299 status code else throw network error dot status code response data status code with the data. All right, so you might be looking at this and going, what the heck is this right there? Okay, so this is called the pattern matching operator. It's used with ranges, and it's basically saying that does this status code exist in the range that's defined here? So now that that's done, we can return our data. Cool, we're done. So all of that to make one request. Now, keep in mind, I did this in a way to make this generic. So you can use this for multiple different types of requests, not just a simple GET request, but post, patch. I guess you could do delete if you really wanted to with this one. Just a little odd having a JSON dictionary here and using a delete, but c'est la vie, you can still use it for delete. So I did this so it's reusable. The more non-reusable you get with these things, the more rigid it is, the more boilerplate and less scalable your app is. So when it comes to things that are going to be used quite a bit or for various different reasons, make it as generic as possible. It does take more time, but it's helpful. So this is very useful for passing back the raw data. The problem with this is we have to map that data to something. Now, so we can't always know what the caller wants to do with this data object. So we have to have at least one request that passes the raw payload back, or the raw data that comes from the server back to us, so we can handle it in like unknown ways. But one thing that's very useful is if we don't care, or we know for a fact that we want to transform that data into say a decodable class, we want to be able to define that class and just have this request do it for us. So that's what we're going to do. We're going to make a new function called request, and we're going to use a generic called response type, and it's going to be decodable. And it's going to pass back, it's going to be async throws, pass back the response type. Now, I'm not making this optional here, and I didn't make either of these because it's throwing an error if it would ever be nil. So you're fine to actually return a non-optional here. So we're going to say, well, we have to pass in a couple things here before I get too ahead of myself. URL, Actually, what I'm going to do is I'm going to copy all of this stuff because it's basically the same. JSON dictionary, except one thing's different. We have a response type. Any equals nil. We're going to say let data equals try await, and we're going to reuse the same request object we just created. Some of this stuff over. Well, sound dictionary. Just fill these in. So now we have the raw data, right? So now we can say return try JSON decoder dot decode response type. Oh, response type. There we go. From data. Now my response type is actually wrong here. It's response type dot type. Now, technically speaking, so there's a couple things here. So when you're working with generics, there's a couple different ways you can do things. So let me explain why I actually pass in this response type. We don't technically need that. But when you're working with it or you're trying to show a person how to use it, it makes a lot more sense to define it up here explicitly in the parameters than to try to use the magic of generics to kind of handle defining this generic type. Let me explain what I mean. I'm just going to make a generic function here so I don't have errors. If I'm trying to use this, I could have said let response access token equals request, the response type, right? And then I can go ahead and I can actually like write all this stuff out, right? Through this, the system would say, oh, because I can tell that the type of property this is access token, it can then reason on what that generic type is just from this right here. However, it's not really apparent from the developer that you need this. So if you don't define this right here as a parameter, a developer might come down here and be like response equals request, you know, what have you, dot, 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 whatever in here. But the compiler would then be like, I don't know what that is. So just to make things easier on ourselves for the future, that's what we do. We say request, and then we pass in the response type here. We could say access token.self, and then that defines it. So it's clear what's happening. It's a little bit more readable with that. So just an FYI on why I pass in a response type rather than just using the compiler to determine that for us. Okay, so that's it. We're done. We are done with the network layer, and we're definitely done with the access token stuff now too. So now you have a fully functional boilerplate to make network requests and to handle access tokens. A little bit longer of a video than I expected, but everything's in here now. In the next video, we'll actually be finishing up. The next video might be a little long, but it's going to be the last video in the series, and we'll have a fully functional app that can register for an account, log in, fetch a access token, store it, and then use it to fetch secure data. So that's it. So I will see you in the next one, and happy coding. Let me know if you have any questions down in the comments, and I'll see you in the next one.